call this class? Okay, I think you mean this. So you don't really understand. Oops, hold on a second. It doesn't show to you. All right, now you can see it. So you're confused with this, right? Okay, let's see attendance. Attendance is 20% of your grades. So gradually, I'm going to put homework, classwork in here. So attendance is 20% of your grades. So basically, I'm starting with 20. Starting with 20, forget about the percentage here. Actually, I could do 100%. Then in the end, it's going to be 20% of your grade. Maybe that's what confused you here, like a 20%. So starting with 20%. Let's see the first one, right? Let me find you. So that's you here. So you attend last class. So I started with 20. If you miss one class, that's going to be half points lower. So you see people 19.5. That means this person did not show up the first class. Does that make sense? If this confuses you, I can change it to 100%. And each time I just deduct 5 points, 5%. If that makes more sense. Okay. Any other questions? Okay, Raw, yeah. What's your question?
Hello, I just answered in. Where do we submit the homework? The email to it?
Oh, not yet. Okay, so tomorrow.
Yeah.
Tomorrow we're going to have a departmental meeting about the homework.
Mm-hmm.
So we will talk about, right, should the students what to do with it. So for now, don't worry about it.
Okay.
It's just do it. I'm going to call people to show today.
Okay.
So I assigned 1 to 48 up to 159. We're going to go over this homework.
Okay.
All right. Any other questions? So how I'm taking the attendance, I take a picture of it. Let's see, now it's time, right? It's 6:06. So I'm taking pictures of people who are on time. And in the middle of class, I'm going to take another picture of it. So this tells me, who are here on time. And lateness will be deducted like a 2.5. Is participation grade included in attendance? Yes. Yes. So make sure when I ask the questions, you answer it. So today I'm going to call people. All right. I'm going to call on you to show this homework I assigned to you. So that's how I give you. But sometimes you get lucky. Sometimes if I don't call you, okay, you don't get anything. You get full credits also. But if I call you, you didn't do your homework, that's bad. All right. How do you want us to show the homework? Because I don't have a webcam. You can type in the chat. You can type in the chat, or you can speak. You can speak, all right? Now let me share this homework screen with you. Okay. All right, so I assigned with you 148 up to 159. So basically, this is important, right? The fundamental theorem of calculus, part 1. And today we're going to learn part 2. So this homework is to practice on the fundamental theorem of calculus, part 1. Okay, you can do screenshot. You can share. I will allow you to share. What if the answer is wrong? That's okay. All right. So the answer is wrong. It's okay. The answer is wrong. So what's important is you tried. You finished the homework. Sometimes, you know, if you get it wrong, that gives me opportunity to make corrections. Right. That's okay. Don't worry about, you know, your answer is not totally right. All right, so let's start. I'm going to use my phone also. Let's see. Oh. Let's start with, I'm going to call, so this is a Li Zheng, a Z-H-E-N-G. So you see yourself on the first one on the list. So that's the attendees. On the attendees, so first one, I don't know how to pronounce your name right. Alejandro? Li Zheng, Lizheng. Are you here? I can make you presenter if you want to share your screenshot. Otherwise, you can talk or you can type in the chat. It will be a little bit difficult to type in the chat for this. Oh, okay. Doing homework is so important. All right. Doing homework, so try next time. Try next time. All right. So try next time. All right, so Alexander, second one on the attendees. Alexander, are you able to show 148?
Actually, I wasn't able to find where this is. Text on math.
Oh, do you have account, Lumen account?
Lumen?
Yeah.
No. I did the open math and
Not Lumen. I'm sorry. I'm so sorry. So sorry. I said something wrong. Totally wrong.
okay.
Lumen is for Hunter College. I mean my open math.
Yeah, I have that.
My open math, right?
Yep.
Show you where to find them.
And then to find 1.3.
Right. You find the 1.3. Let's see. Let's go to my Lumen. Okay, this is my Lumen, right? Are you able to get into this page?
Yeah, I see that.
Okay, you see the second one, a calculus test?
Oh, okay, I gotcha. Okay.
You click on it, this basically is our textbook. So 1.1, 1.2, 1.3, we're at 1.3 now. All right.
All right, I see it now. All right. But yeah, I'll know for next time. But I wasn't able to find it this time. Sorry.
That's okay. That's okay. So it's good for me to know what's going on with you guys. And 1.3. All right. Okay. Ali, A-L-I. Are you able to show it? 148?
Yeah, I have it on me, but I don't know. I'm not able to show it.
Okay, let me tell you how to share. So do you see an arrow on the right bottom?
Oh, yeah. So you want me to, but I don't. Hang on one second. I can,
okay.
so I can upload the picture to my computer if you just give me like a couple minutes.
Sure.
Thank you.
Sure. You could do that. So everyone, you can share. Once I make you presenter, you can show to class, just like I share my screen with you. You can share your screen with us. Or you can use the whiteboard, right? Once you click on the share content, they give you a couple choices. You can share files. If you save it in the file, you can share application screen, which means your computer screen, or you can share a whiteboard. So on the whiteboard, you can, you can just write on it. Can we just type our final answers out? You may, but you need to tell me, you need to tell us, why, why the answer is your answer. Okay, so while we're waiting for Ali, let's see, Damani, can you show 149? I can make all of you presenters. I'm not sure if I see your name right. That's Remy, Damani, Remy, Gaylord. So sorry if I don't see your name right. So Damani. How will this work on iPad? Oh, on iPad, I'm not sure. On iPad, I know you can share your screen. It's the same process. Once you click on the arrow, share content, then you can share your other screens.
Professor?
Yeah.
Can I just answer 148 for you?
Yeah, go ahead. Thank you.
Okay, I'll do that. Okay, is e to the negative x to the second power?
Oh, that's a golem?
Yes.
Oh, you're answering 148?
Yes.
Oh, okay. Hold on a second. Can you explain to us what you did?
So it goes 1 to x, right? Oh, what's that thing called? The squiggly bracket? I forgot.
Oh, the integral sign?
Yes, we're trying to find the derivative, so it goes 1 to x, so I've substituted the t for x.
Right. What allows you to do that?
So we're trying to find the derivative negative d over so we're trying to find the derivative of negative d over x.
Right. We're trying to find the derivative of this integral.
Yes. So
Yeah. So your answer is right, but I'm asking what makes your answer right?
using the fundamental theorem of calculus.
That's right. So what do we have to check? So the lower limit one is the one in the domain of the integrand. Yes. So the upper limit is x. So that means we can use the fundamental theorem of calculus part 1. So we take a derivative of that. That's exactly e to the negative x squared. That's right. Anyone has any questions? Okay, Darren May 149. Let me see. Yes, go ahead, Darren. The answer is e to the cosine x. That's right. Same reason, right? The lower limit is 1, upper limit is x. Then the derivative of the integral is e to the cosine x. Okay, great. Yes. Yes, according to fundamental theorem of calculus part 1. Okay, great. We just replace the x to t. That's right, because the lower limit is a constant, which is in the domain of the integrand. The upper limit is just x. All right, so we have 148, 149. Anybody up to 150 or 151? Oh, Bi Xin. Yeah, Bi Xin 150, go ahead. Oh, Damon, maybe you try 151 then. So Bixin 150. Bixin's answer is the square root of 9 minus x squared. Yeah, because the lower limit is a 3. 3 squared, we have 9 minus 3 squared, which is 0. Square root 0 is 0. So 3 is in the domain of the integrand. The upper limit is x. What do? We just switch y into x. Exactly right. So the derivative of this integral is just square root of 9 minus x squared. Okay, great. All right, Damon 151. Okay, good jobs, guys. Damon, are you ready for 151?
Sorry, I was on mute. Can you hear me now?
I can hear you now. Yes,
Okay,
go
sorry
ahead.
about that. So I just click on
That's
share
okay.
video, right?
Oh, you want to share? Yeah, you can share
Okay.
your screen.
Well, it's only allowing me to share video, not my screen. So
When you click on share content, you have 4 options. You can share
oh, I see it. I
whiteboard.
see it now. Sorry. I can see
Okay.
it. Actually, it's not even giving me the. It says primary content on here. It's not giving me the ability to share anything.
Oh no.
I clicked on share content. It just says primary content, and that's it. There is no. I'll explain how I got the answer. So you
Okay.
just taking the derivative of course, x over the integral for the ds over the square root of 16 minus s squared. What I did was I substituted x for ux. I did it the long way, and so I placed du over dx as a numerator to replace dx over the square root of 16 minus x squared, and of course du dx of is pretty much du of x is just 1 over the square root of 16 minus x squared. So it's
You said you're doing 151, right?
yes, that's ds over the square root of 16 minus s2, right?
That's square, right? So you were saying you're using u substitution.
Yes.
Why do we need to use u substitution?
Well, I was using the fundamental theory to the first one, so where you substitute x for ux, and then you take the derivative of du over dx for the numerator to get, since x is a variable, the derivative of x is just 1, and that over.
Okay, there's no need to use u substitution because the upper limit just x. But for 152, we need a u substitution. We need 153, 154, we need to use u substitution, right? But if you use u substitution, that's fine because the derivative is just 1. It doesn't change anything. Because
Okay,
in the fundamental of calculus, right, the upper limit is x.
Okay.
All right.
Gotcha.
Okay.
All right. Thanks.
All right. Okay. Thank you. So that's 151.
I had a question. Can anybody else share their screen? I don't know if it's just me who can't share their content. I don't know if anybody else is able to.
I think I can.
You can?
Oh, okay. So who's this? Oh, Damon, go ahead.
No, I answered already.
Damon, you want to answer which one?
Oh, no, I just answered 151.
That's right. No, Damon can answer another one. He can pick up another one. 151, 152, 153, 154. Damon, you want to try 155?
You want me to do another one?
Oh, that's you, right? Okay, Damon. That's I'm so sorry. I thought I was calling another person. Okay, 152. Ali, 152.
Oh yeah, I think James wanted it. I'm not sure if he wants to do 152. If not, I'll do it.
Oh, James wants to do 152. James? Okay, go ahead, 152. You can talk to us. Okay, so first you use the power rule. T squared over 2. Why? Hold on, James. We're using fundamental theorem of calculus 1. So your answer is x squared over 2. That's not right. The answer should be 2 times 2x, 4x. 3x, Darren? Why 3x? Should be 4x, right? Well, let's talk about this one. Okay, James, how did you get your answer? We're doing 152, right? Three x. Okay, the only thing, let's go to the whiteboard. Right, we're using chain rule. Okay, James, watch this. So fundamental theorem of calculus part 1 is saying the lower limit is a number. The upper limit is x. So if here we have, if the integrand is some f of t, then dt, when we take a derivative of this,
I think, Professor, is because the upper bound and the lower bound were x's instead of one of them
oh,
just
the
being
2x,
x.
right, that's 2x. Oh no, I'm talking about, right, hold on one second. I'm talking
sorry.
about fundamental theorem of calculus yet. So this is just 1x for now. So this is just 1x for now. So when we take a derivative, we take a derivative of this. So let's make sure we understand what's going on. And then this stretched s integral sign, and this dt is a pair. All right, so this means, remember what does this mean? This means to take a limit, you know, the n summation. Then we take a limit, let n run to infinity. Right, make sure we understand the integral sign. So we have a variable I with the index. Go from 1 up to n. Right. Then this is the areas of all the rectangles. F of x. Then delta x. Well, x is a chosen x. Right. So that's what it means. This is what it means. The integral sign with the dt is this. Okay. So the middle one, f of t, we call the integrand. So fundamental theorem of calculus is saying if it's in this case, so that just equals to f of x. Right? Now, 152, right? Or 153. The upper limit is 2x. If it's 2x, we can use u substitution. So basically, when we get f of x, we have to multiply by du dx. Because the dt becomes, because dt, if we use u substitution, dt becomes du, because dx over dt. So you see from here, we have a du dt. Because we changed the variable to du dt, right? If we use u substitution, we said, okay, let u equals to 2x. Then du dx is 2. It's very difficult to write down this. Du dx equals to 2. Or sometimes we would write du equals to 2 times dx, right? Because of this, because we changed the variable to du, right? So du, we think about du dt equals du dx, dx dt. So we have this one, right? That's why we have du dx. So what's du dx? Let's just multiply by 2. So multiply by 2, this is 2 f of x. But what's of f of t? F of t in the question is just t, right? What's t? T is 2x. T is 2x. So we have 2 times 2x, which is 4x. Just by chain rule. By chain rule. But when we substitute the variable t is not only x, it's 2x. It's this guy. Okay, any questions? So Paul, do you see why it's not 3x? James, it's not 2x squared minus x squared divided by 2.
Oh, can you hear me?
Yeah, who's this?
This is Paul. So for 152, the question has two variables. The integral has 2x for the upper limit and x for the lower limit. So in the textbook, it gave an example for that, and you have to split it into two integrals.
Okay, you're right. Oh, you're right. Yeah,
Yep.
I missed this part. All right, I missed the lower limit. You guys are right.
So do you want me to explain how I did it?
Okay. Yes.
All right. So basically, it's what you did is half of the integral after you split it.
That's
so you're
right.
at the start, you're going to have integral 2x upper limit, x lower limit. So you have to split that, and then you get an integral with 0 at the upper limit, x at the lower limit, plus the integral you just did with 2x upper limit and a constant as a lower limit. And then for the 0 and x one, you have to then take you have to reverse it. So you'd get an integral with x on the upper limit, 0 on the lower limit. And then that you apply the fundamental theorem of calculus part 1, and you'd get it's just equal to negative x. So then you're doing negative x plus the 4x you just went over, and you get 3x.
Exactly. Good job.
Thank you.
Good job. So because the lower limit is not a constant, because we need lower limit to be a constant. So from x to 2x, what do? We split into x goes to 0. It doesn't have to be a 0. It could be any constant. Then plus 0 to 2x. And one of the property of integral is we can change the upper limit and lower limit. When we change, they introduce a negative sign. So we will switch x and 0, lower limit and upper limit. Let's just introduce a negative sign. So this one will give us 4x as I did here. And the first one will be negative x. So that's why 4x minus x is 3x. Good job. You guys are right. Great. Now let's do where does I want to share this one. Oh, okay, I have to do this every time. Okay, that's 152. Now 153, let me see who wants to show 153.
I can explain how I did it, Professor.
Okay, go ahead. Thank you.
All right, so first, we know that the integrand t is actually, or pretty much f of t, and we also know based on the fundamental theorem that f of t is equal to big F prime of t. And so we basically get the derivative of big F prime of t on the with the limit bounds being upper bound square root of x and lower bound 0, and then you get the derivative of big F of square root of x minus big F of 0. And because f of 0 is a constant, that pretty much turns into a 0. And after that, it is f of square root of x times so based off of the chain rule, I got f times square root of, or f of square root of x times 1/2 x to the negative 1/2. And going back to the integrand, which is just t, we could replace the t with square root of x. And we multiply that by 1/2 x to the negative 1/2. But because it's a negative exponent, we have to bring the negative 1/2 to the bottom of the denominator at 2. So I got 1 over 2x to the 1/2 times square root of x. Square root of x times 1, so it becomes square root of x over 2 times x to the 1/2. Then the x to the 1/2 can be converted back to a square root of x, so that the square root on the top and bottom can cancel, and that leaves me with 1/2 as my final answer.
Okay, the only thing confused me when you talk about 0. We don't have a calculator at 0. As long as 0 is in the domain of the integrand, that's fine. We just use fundamental theorem of calculus. We just do t, right, substitute into square root of x, then du dx, basically use u substitution. U equals to square root of x, we find du dx.
But 0 is, would it be considered like a constant and it just canceled out to 0?
Right, so it doesn't cancel out. It's just we use the fundamental theorem of calculus. It says that the bottom, the lower limit has to be a constant to be able to use the fundamental theorem of calculus part 1.
Right.
But we don't do anything with it.
I got you, yeah.
Okay, all right.
Is 1/2 still correct though?
You should get a square root of x divided by 2, right, divided by 2 square root of x is 1/2. Yes, I agree with you.
All right.
Yeah. Yes, the answer is 1/2. Because here the integrand is t. The integrand is t, right? The integrand is t. So we just get square root of x. But the du, if we use u substitution, so derivative of square root of x is 1 over. So in the denominator, we get 2 square root of x. So square root of x divided by square root of x is 1. So we're left with 1/2. Anyone has any questions? All right, so that's 153. Now 154. Anyone wants to show 154? Damon? Okay. Anybody else? I want different people to show it. Let me call. Damon. Fu Jun Pan. I don't care if you make mistakes, or you can tell me your reason. You're not able, you haven't done anything yet. Fu Jun. Oh, square root of 1 minus sine square. Yeah, okay, he typed it in the chat. So his answer is square root, so 154. Square root of 1 minus sine square x. Sine square x multiplied by cosine x. Okay, I agree with you. Just be careful when you do sine x squared. Okay, you probably want to do this. You could write this way, sine x squared, or you write sine square x. All right, the way you write sine x square by convention, just by convention, equals to sine x squared. That means the angle is squared. Okay, great. All right. Square root of 1 minus sine square. Well, Fujin, what is 1 minus sine square? Oh, what's sine square? Sine x squared plus cosine x squared. Sine squared plus cosine squared of the same angle equals to 1, right? By Pythagorean theorem. So square root of 1 minus sine square is just square root of cosine square. And square root of cosine square is just cosine. Cosine times cosine. The answer should be cosine square for this one, right? 154. Anybody agree with me? Okay, Paul said yes. Okay, Golem says 1 plus sine times 1 minus sine. Right.
Oh, in square root. I don't know.
In square root.
Yeah.
Right.
Sorry.
That's a different, like you did it right, but here we don't want to use it. So that's the difference of two squares. If it's a difference of two squares, we can always split into conjugation. You know, one is plus, one is minus. You did it right, but this wouldn't help us for this. Do you see it? You see in the chat?
Yes. So is square root of 1 plus sine x, sine x, then times 1 minus sine x, and those are under the what's it called?
Square root.
Then cosine x. Cosine
right.
x.
That would. Right. What I mean is that wouldn't help us. So what we want to do is we want to use the identity. It's one important identity. Let me use the whiteboard. So sine.
Professor?
Yeah.
Do we find the integral?
Hold on a second. I want to talk about this.
Okay.
Okay. Sine square and the cosine square of the same angle equals to 1. That's why in this one we have a square root of 1 minus sine square. So do we see that's just a square root of cosine square? Right? Square root, and square cancel each other. So that just equals to cosine x. Anyone has any questions about this 154? So that's why in the end we get a cosine x times cosine x, which is a cosine square x. Okay. So Golem, you see why I don't split into the conjugation 1 plus sine and times 1 minus sine, because that wouldn't help us to get out of the square root sign. I want to use this identity. Okay, great. All right, 155. Who wants to show 155? Let's go back to 155. We'll have cosine to 1. Okay, anyway, let me call. Let's see. Kelly, can you help us with 155? Kelly, are you here? Okay. Oh my goodness. How? Okay, I'm going to spell out your name. Mashrur. And maybe you can teach me how to pronounce your name right. Mashrur. Mashrur. Yes, Kelly, I called you. If you didn't answer me, I'm going to take you not a present, okay? All right, so 155. Can you try 155? All right, so Kelly, prepare for 155. And Mashrur, Mashrur. If you are not respond to me, I'm not going to take you. Oh, you're here. Okay, great. So do you want to try? Do you want to try what's the next one? 156? Oh, Kelly, you can, so there are a couple of ways you can present your work. You can use a whiteboard. Okay, what I can do is I can allow you to, you can share your screen with us and make you a presenter. You can do on the right bottom, you see an arrow, share content. You can use whiteboard 156. 156. You can use whiteboard or you can share your screen with us. Yeah, let me delete all this. Or you can type it. It's difficult to type in the chat. Oh, you missed last class, I see. Okay. Yeah, I see your writings now. That's okay because this is your first class. You missed the first class. So, but please watch. We're going over. So by doing this, we're going over the material, the important material in the first class. So next one, so we have, that's 156. So we have 3 more. Okay, that's fine. Kelly, you're saying that equals to sine. So, okay, what is, let me write here. So what is a fundamental theorem of calculus part 1? Let's make sure of the theorem first. The theorem says, make a little bit too. It says the derivative of this integral with a lower limit to be a constant, upper limit just x, and the integrand is f of t. T is like a dummy variable, okay, dt, then dt. So let's make sure we understand this, all right? Right. So integral, so this is integral sign from a to x. All right, so here, Kelly, do we have a lower limit as a constant? When this happens, we can use the fundamental theorem of calculus. We say, okay, that equals to f of x. Right? That equals to f of x. And if this one is not x, it's something else, right? We use u substitution. Then in the end, we just multiply by its derivative. So what's the derivative of x? It's just 1, right? So this derivative of x is 1. That's why 1 times f of x, just f of x. So what do we do with this? The cosine x, so we need to flip, right? So we need to flip the integral sign, put down 1 on the bottom, cosine x as upper limit. But when we do that, that introduce a negative sign. So when we flip the lower limit and the upper limit, that introduce a negative sign. So Kelly's answer is not too far from it. It's 1 cosine square x or cosine x parentheses square multiplied by the derivative of cosine. What's the derivative of cosine? Which is a negative? Oh, negative, negative, positive. I think she meant this. So negative, negative become positive. So now, Kelly, what is the square root? What's 1 minus cosine square? The sine square, right? Right. So this one in the end is just sine x. Then sine x times sine x. So the answer of this one should be sine square x. Okay, sine x times sine x, we write down the square, write down the 2 on top of n. So sine square x. That means sine x times sine x. All right, anyone has any questions? Am I sure? Does this mean a little bit? Yes.
Can you show how you did it, like step by step? Like I kind of got lost.
Oh, okay. Okay. Let's do that. Let's start from the very beginning. So we want to find the derivative of this integral. In the theorem, this integral is a capital letter F. All right, the carrier. So then, this is 156. 156. One is the upper limit.
This is 155, x. Professor.
One what? Oh, 155.
Yes.
Thank you. It's 155. Thank you. So inside is the square root of 1 minus t squared, right? Very difficult to write this. Oh, then dt. Okay, let's comparing this to fundamental theorem of calculus part 1. I'm going to write on the side. Okay, so this is F T C part 1. All right, super important theorem. We use this all the time in calculus classes. Derivative of this integral starting from a constant and x. Then we have some integrand. f of t or f of y dt. And we call t here dummy variables, all right? Sometimes you see f of y dy or f of s ds. As long as this variable is t, this is d of the variable, that's fine. So we call these dummy variables. So what do we need to check? So if this, so this equals to f of x. All right, so that's the fundamental theorem of calculus part 1. So we want to use this. This little f, okay, this is not a capital F. It's just so difficult to write it. This is a little f. So this f is exactly this f. So those two f exactly the same, okay? So let's compare this 155 with this theorem. So we have something, okay. We have this constant on the bottom, but here we have the function on the bottom. So we want to switch the lower limit and upper limit here. So we want to write down d dx we want to write 1 here, cosine x on the top. We want to switch the upper limit and lower limit. But when we do that, that introduce a negative sign. All right, we have to write down negative when we switch the upper limit and lower limit. Then the rest is the same. I'm not going to write it. So this equals negative, while the inside, so the integrand is 1 minus the upper limit, cosine square. Then what's the derivative of this upper limit? Negative sign. Negative sine x. I can't find my stylus. Well, now what's 1 minus cos square? That's sine square. Right, by identity. Because cos square, sine square equals to 1. So 1 minus cos square equals to sine square. And square root of sine square, just sine. So this, we get negative sine x. Negative sine x times negative sine x, that's positive sine square x. So the answer for this question is sine square x. Okay, any questions? Okay, I need to find my stylus. All right, so now 156. We're doing too slow. 156. Anybody wants to show 156? Oh, Zachariah.
Yeah.
Okay. Okay, thank you.
Wait, which one is 156? Okay, so I substituted radical x into the t squared and t to the fourth, and then I multiplied that by the derivative of radical x, which is 1 over 2 radical x. So that is x over 2 radical x times 1 plus x squared.
Okay, so let's see. So in the end, you get x over
2 radical x times 1 plus x squared.
2 radical x times 1 plus x squared. Yeah, I agree with your answer. Yes.
Okay.
Yes, thank you.
Also for the attendance, I joined like a few minutes late. I don't know if I'm.
Oh, okay. All right. Yeah, I see I have more people. I'm gonna take another picture of it. Okay, thank you.
All right, thank you.
Okay, Woodley, you want to do 157? If anyone has questions, let me know. 157, Woodley. Well, 2 more to go. You want to talk out, or you want to share your screen, or what do you want to do? Maybe your mic is off, it's mute. I cannot hear you.
Can you hear me now?
Yes.
Oh, okay, got it. Sorry.
Okay.
So 157. So I tried using substitution. I substitute x squared with t, and then I got let me see, 2u squared over 1 plus u squared, and then let's see, and then I tried finding the integrals with that.
Well, what do you mean? You don't need to find the integral of that, right? All we're trying to do is use FTC part 1.
Oh, okay.
Right? So you use u substitution, that's right. So you define u of x equals x squared. Then du dx would be 2x. Right?
Oh, okay.
So
Yeah.
all you have to do is to change the integrand, write down the integrand as square root of x squared. That gives you x divided by 1 plus x squared. Then multiply by 2x. In the end, that gives you your f of x, or this whole thing. This whole thing in the end is just a function in terms of x. So 2x squared divided by, I'm going to write down here, 2x squared divided by, I think you have the right answer. You just have a problem to explain it. 1 plus x squared. That's it. That's the answer. It's a function.
Oh, yeah, that's what I got. Yeah.
That's a function. Right, you don't have to do integral or anything. That would be FTC part 2. We're going to integral. We're going to use anti-differentiation. But for now, we just use FTC part 1.
Okay.
All right, 158. Okay, thank you. 158. Let me see. The carrier. Okay, let's see. Raw. Actually, before raw, R-A-U-L. Yeah.
I didn't get up this far. I just transferred in last night.
Oh, okay, that's okay.
I'm doing it right now.
Okay, what about Rajeev? R-A-J-E-E-V. I know I pronounced your guys' name wrong. I'm so sorry. Teach me how to say your name right. R-A-J-E-E-V. You weren't sure. Okay, how to do this? All we're trying to do is to use fundamental theorem of calculus part 1. Okay, let's see. So raw, can you try? Do you want to try it?
Sure. What number?
158.
158.
Right.
Okay.
Thank
First,
you.
Applying fundamental theorem, right? So plug in ln of x and then e to the ln of x, the derivative over e to the 0, or minus e to the 0.
Why minus?
We're
trying to use a fundamental theorem of calculus part 1, not part 2.
Give me a second.
Okay, we don't do anything with the lower limit.
Okay.
Yeah. That just equals to, so this one, so in the end, this is just a function. The function is the integrand. We change the t into the upper limit, so we get an e to the ln x. What's the e to the ln x?
E to the ln of x is just x, right?
Just x, right? So just x. Then multiply by derivative of ln x. What's the derivative of ln x?
It's 1 over
1 over x. What's x times 1 over x?
1.
That's 1. So the answer for 158 is just 1.
Okay.
Okay, all right. Now 159, last one. Let's see. Shehayar, S-H-E-H-A-R-Y-A-R. You guys have beautiful names. I just don't know how to say it right. S-H-E, Shehaya. S-H-E-H-A-R-Y-A-R. Are you here? Okay. Do you like to try it? Last one, 159. We're missing so many people.
I'm sorry, Professor. Did you say the answer for 158 was 1?
Yes.
Okay, thank you. Just making sure.
Do you see why is 1? Do you have questions?
No, I know. I was just making sure that it was 1. I got it. Thank you.
It is 1. It is 1. You're welcome. Do you want to try 159?
Who, me?
Yeah.
Oh, yes, sure.
Oh, no. That's payment.
Yes, okay.
Okay. I want to share higher, S-H-E-H-A-R-Y-A-R. If you don't respond to me, I'm not going to take you. I'm not going to take your attendance, okay?
He answered in the chat.
So I guess this person is just not here. All right, let's see. It doesn't make sense. I can see you, but you're not here. What are you doing?
He answered in the chat.
I'm sorry?
He answered in the chat.
Oh, he answered in the chat. I'm so sorry. Yes, we'll use substitution. Oh, okay. All right, you answer in the chat. I'm sorry, I didn't see this. I was too busy writing down things. Okay, you are saying you use substitution. All right, that's fine. So if you use u substitution, right, u of x equals e to the x. What's du dx? All right, that's fine. That's fine. All right. Let's see next. Try J. Trejay. Okay. Do you like to try 159? All right, that's fine. Let's see. Zainab, Z-A-I-N-I-B, Muhammad. Zainab, are you here? Oh, yes. 159, yes, the last one. The last one you were seeing, let's see what it is. 2x times e to the x. Where does ln, oh, I see. Let's see. So we have ln e to the x squared, right? E to the x squared. So that's ln e to the 2x. That's just 2x. Then 2x times e to the x. So 2x e to the x. That's right. Okay. I explained to you, for you. Zachariah. Yes, Zachariah. That's so Zainab has the right answer, 2x e to the x. Preferably next time you can talk or you can explain how to do 159. Okay, let's go to do 159. Oh, actually, Zainab, do you like to explain your answer? $156. All right. 156 is square root of x t squared 1 plus t raised by 4. So that's 156. 159 is 1 to e to the x ln u squared du. Okay, let's go to whiteboard. Remember this, okay? So your job, last class I already asked you to remember this, okay? For the first class, what's important is this, FTC part 1. For today, what's important will be FTC part 2, right? Remember this. Lower limit, upper limit. Lower limit is constant, upper limit is some function of x. But here it's just identity function, right? Then when we take derivative of this integral, we just get the integrand by changing the dummy variable into x, right? So x is a real variable. So t dt is just dummy variable. So in the end, so this just, we get a function. The function, just the integrand by changing the dummy variable into x, then multiply by the derivative of this upper limit. In this case, the derivative of the upper limit, or derivative of x is just 1. So that's why we get f of x. So make sure you remember this, okay? If you don't remember, write 10 times. Make sure you understand this. If you don't understand this, you won't be able to use this theorem. Okay, now let's go to 156. I don't have a stylus, so it's super difficult for me to use my fingers to do this. Let's see. So 156 we have, so we want to take derivative of this integral. Lower limit is 1, right? It's 1. Upper limit is square root of x. Integrand is t squared. We see that's f of t, right? T squared divided by 1 plus t raised by 4. dt. Okay, so by the fundamental FTC part 1, we just get, so the upper limit is the square root of x. What's the square root of x being squared? So let me just do this. Let me just write it. So we have a square root of x squared. Then divided by, yes, that's x, right? 1 plus square root of x raised by 4. Then multiply by chain root, derivative of a square root of x, which is 1 over, that you should remember by heart. Derivative of square root of x, you should remember by heart. It's 1 over 2 square root of x, right? So we simplify this. Square root of x squared is x. Square root of x raised by 4, just x squared. Right? Then just multiply by this. Well, we can write down 2 square root of x up front. Well, we can simplify this, right? We can simplify. We simplify this with x. Then this becomes square root of x in the numerator. The bottom, just 2 times 1 plus x squared. Right? Square root of x divided by 2 times 1 plus x squared. That's it. Any questions for this? So this one we get x. What's x divided by square root of x? That's the square root of x, right? And then that's how x1. 156. Who asked 156? Okay. All right, great. Now let's do 159. 159. We're trying to find the derivative of the integral. Goes from 1 to the e to the x ln u square. You see the dummy variable is a u now because it doesn't do anything to us. That's why we call dummy variables. So as long as this is u du, it could be t dt, doesn't matter to us. So this we get ln e to the x square right? We just change u to be our upper limit. Then we multiply by derivative of e to the x. What's the derivative of e to the x? It's itself, right? Now we just do the calculation of this. E to the x squared is e to the 2x, right? Then with ln e to the 2x, we can move 2x up front. So we get 2x times ln e. What's ln e? 1. Right? Because ln is log base e. Log base e, value e, that equals 1. So 2x e to the x. Shahaya, does this make sense? Any questions? Okay, we have a half hour. I'm going to talk about fundamental theorem of calculus 2. Shahaya, you are asking question 159. Does this make sense to you? Okay, all right. So we don't have much time. Let's go to the textbook. Talk about the second part of FTC. Oh, not here, up here. Which we use all the time, which is easy to use, and then we use all the time. Okay, here. Do you post the recordings on Blackboard? If you don't know how to find it, I'll show you after class, okay? So I record every class, and the recording is there. The website saves, CUNY Blackboard saves automatically. I'll show you, just remind me, I'll show you how to find them. So second part of fundamental, okay, FTC, second part. So basically evaluation. Now we're going to use anti-differentiation with definite integrals. So let's see, this is a definite integral, right? So lower limit is a constant, upper limit is a constant. So A, B are some numbers. All right, so take a derivative. So we integrate the integrands f of x from A to B. That's what it means. What's the picture? The picture, let me see if I can find the picture. The picture is this. The picture is, so A in this case is -2, B in this case is 2. Right? We want to find the area under the curve. Well, in this case, we will get negative area, but that's fine, because that's by pure mathematics. So function, so that's the function, right? If I want to find area from 2 to 4 under this curve, right, I will set up the integration, lower limit to be 2, upper limit to be 4. The integrand will be t² - 4, then dt. The variable is t here. All right. So this means we have a function f of x, and we want to find the area under f of x from a to b up to b. So if the integral is continuous over the interval a b, all right, a is our lower limit, b is our upper limit, and the whole thing is an antiderivative of fx, then so basically f prime, so capital letter F prime equals to lowercase f of x. So that equals the f of b, f evaluation of the antiderivative of little f, which is capital F, evaluation at b point, subtract at a point. All right, let's see some function. Let's see some. So try to remember this, okay? So now we learned both parts of FTC, okay? Because it's called fundamental theorem of calculus. Without this, there's no calculus. The proof is here, okay? We use summation, then we use the limit idea, always limit idea. Because, you know, limit idea comes from finite world into infinite world. Let's see this one. We want to find the area from -2 up to 2, the area under t squared minus 4 dt. So what do we want to do? We just anti-differentiate. How do we anti-differentiate t squared? Remember power rule? There's a t 2 plus 1, which is t cubed, divided by 2 plus 1, divided by 3, right? So it's a t cubed, 1/3 of t cubed. What is the antiderivative of 4, which is just 4t? Then, so we get a t cubed divided by 3 minus 4t. Then we evaluate at 2. Then we subtract evaluation at -2. So power rule, anti-differentiation, antiderivatives, power rule is this, right? X raised by n plus 1 divided by n plus 1. So here, antiderivative of t squared, that's 1/3 of t cubed. Antiderivative of -4, that's -4t. Then we evaluate it. So we put a long bar afterwards. We put -2 down, 2 upward. So it means evaluation at 2 and evaluate at negative and subtract them. So we evaluate at 2, get this, then subtract evaluation at -2. Right? You know, do the calculation, we get -32/3. Pure mathematics, all right? Because that just means the negative sign here just means the area is under x-axis. That's this. So the area under this curve from -2 to 2 is -32/3. Negative sign means the area is under x-axis. Okay, any questions?
Wait, so you said the negative in front of the number is just means like the area is under the axis?
That's right. That's right.
Oh my God.
Right. It's a pure mathematical idea.
Okay,
right?
so what happens if it, like, let's say, overlaps both of the axes?
What do you mean?
So let's say, can you scroll down? So what if the area, like, let's say, go up to +1? Let's say, can you draw like a horizontal, like horizontal line on 1? Yeah.
Yeah, that's the problem. It doesn't allow me to use it. It's not like a zoom.
Okay.
Zoom will give me pen. So I understand what you mean.
So yeah.
You
so
mean
let's,
here, right?
Yeah, let's use
Let's
our
see.
imagination. So yeah, let's draw a line and shade
You
it.
mean, right, let's see if the interval, the lower limit is -3, right? Can you see my arrow?
Yeah, I can see. So
Right. So if I have -3 here, if we find the area under this curve from -3 up to 3, we will get a positive area too, right?
okay.
Right. You see, that would be positive area. But if I want to do that, that would be positive area subtract the negative area.
So, but aren't we supposed to find the area for everything? Okay, so okay, I see what you mean.
For this case, right? For this case, we just want to find the area in this one from -2. You see the lower limit is -2, upper limit is 2. So that means our interval is -2 to 2.
Okay.
Okay. We'll see more examples. All right.
Oh, I see. So if you subtract, so it's a negative, so negative is positive. So I think that's why. Okay, I understand.
Oh, okay. All right. Good. You solve your own questions. Okay, let's see this one. So we want to find this, right? So we just have to anti-differentiate the integrand, then evaluate at 9, subtract the evaluation at 1. So we do x divided by square root of x. What's x divided by square root of x? We want to simplify this integrand. X divided by square root of x, we get square root of x, right? Or x raised by half. That's just square root of x. Then minus 1 over square root of x. So that's just x raised by negative half. Then we use the power rule for anti-differentiation. We use the power rule, so we'll have x raised by half plus 1, which is 3 halves. X raised by 3 halves, then divided by 3 halves, minus x raised by negative half plus 1. Negative half plus 1 will be positive half, then divided by half. Then we evaluate at 1, at 9, we subtract them. In the end, we get 40 over 3. So let me see if this has a picture. You see this one has a picture. So the function is this one. We'll find the area from 1 to 9 under this function. So that's 40 over 3. So the area, this area is 40 over 3. No units. Okay, this area is a little bit different from the algebra area. Okay,
Professor,
any questions? Yes.
I'm sorry, can you scroll to the top again and from the 6? So I'm trying to convert a little bit further down. So the first conversion from x minus 1. Okay, I see x minus 1. Okay, half. Okay. Okay, never mind. Sorry, thanks.
Okay, you mean anti-differentiation?
Yeah. So.
Yeah.
I got it. Thank you.
Okay, great. Okay, anyone has any questions? So the second part of FTC is all about anti-differentiation. So that requires our skills for anti-differentiation. All right, let's see more examples. Let's see this one. Let's anti-differentiate x raised by -4. So everybody, I just want you to try, type your answer in the chat. When you anti-differentiate x raised by -4, what do you get? X raised by -3 and divided by -3, right? So it's a negative 1/3 of x raised by -3. Yeah. Yeah, Ali, you got it right. Damon divided by -3. Okay. So we evaluate. So we get negative 1/3 of x raised by -3. Yeah, type in the chat. So we just change, we evaluate this at 2. So when we evaluate at 2, what's 2 raised by -3? So actually we can write it as -1 over 3x cubed. We evaluate at 2, we get -1 over 3 times a, so -1 over 24. We evaluate at 1, we just get -1, right? So -1 over 24, subtract -1, becomes +1, so 23 over 24, right? So the difficult part is anti-differentiation. all right? Anti-differentiation. All right, let's see, that's this one. Oh, you're right. Minus 1/3, plus 1/3, right? Because minus negative 1/3. You're right. Minus negative 1/3 become plus 1/3 multiplied by a over a 7 over 24, right? Okay, Paul, it's negative. It's a negative. After anti-differentiation, we get negative 1/3 of x raised by -3, or negative 1 over the denominator is 3x cubed. Do you see Paul is raw? The raw, do you see it's negative? Oh yeah, plus. Okay, you got it. Okay. All right. Anyone has any questions? Okay, basically just anti-differentiation. So that's the second part. Okay, let's do some exercise. Okay, let's start from 170. Let's start from 170. Then let's try 170, maybe up to 174. I'm gonna try also, all right, then to check my answer with yours. See if I did it right. So 170, I anti-differentiate. So anti-differentiate the integrand. Then evaluate at the upper limit. Because after anti-differentiation, we get a function of x, right? Then we evaluate the function at the upper limit. Then at the lower limit, and we subtract them. That's quick. Which one? We're doing 170. We're trying to do, because we have about 15 minutes. I think we can do 170 up to 174. Oh, interesting. Is that right? Okay, I got a negative number for 170, 171. Okay. Negative 7 over 3 for 170. I get an, oh, negative 10 over 6. I can simplify. That's negative 5 over 3. I get negative 5 over 3. Let's see. So 2 cubed That's a over 3. Then 2 squared is 4. So 4, 12 divided by 2 is 6. Then 1, get negative 1/3. Oh, negative 1. Oh, this become plus. I think you did it right. This become plus. So that is 2. So 9 minus 2. So this is 7 over 6. 7 over 6. 7 over 6. Then negative 10, negative 20. Oh, negative 20, negative 13. I don't know. I got negative 13 over 6 now. Okay, I think we all get different answers. So this is negative 1/3 plus 3 over. Oh, hold on. No, minus. Still minus. Minus 3 over 2 because negative 1 squared is positive. So that becomes negative 10, then plus 10 over 6. Okay, I got a negative 5 over 3 for first one. So we have negative 3 over 2. Interesting. No one have the same answer, huh? Oh, negative 3 over 2. So at least 2 people have negative 3 over 2. I get 5 over 3. Oh, Darren get positive. All right, let's try this. So we have negative 1 to 2, x squared minus 3x dx. Let's take to the whiteboard. All right, we all get different answers. Most people get negative 3 over 2. That's a good sign. That's a good sign. So we're going from negative 1 up to 2. The integrand is x cubed. Oops. X cubed minus 3x. Then dx. All right, so this is our integrand, x cubed minus 3x. Let's make it a little bit thicker. So first we anti-differentiate. So anti-differentiate x cubed. No, x squared. That's x squared, not x cubed. X squared. So anti-differentiate x squared, we get x cubed divided by 3. Anti-differentiate 3x, we get 3x squared divided by 2. By power rule, right? Because it's definitely integral, we don't care about adding c. We're not going to add c to it. Then we want to evaluate at the negative 1, at the 2. Right, so when we evaluate, let's tap here. So 2 cubed, that's 8. So I get a over 3, right? Minus 2 squared is 4. 3 times 4, 12. 12 divided by 2, 6. So minus 6, right? So when I evaluate at the 2, I get a over 3 minus 6. Then subtract parentheses, right? Negative 1 raised by 3, that's still negative 1. So I get negative 1/3. Then minus negative 1 squared is positive 1. So I get negative 3 over 2. Get this. Okay, a over 3 minus 6. A over 3 minus 6, 24 over 3, right? Oh, I did this one wrong. Oh, hold on. No, I did it right. So that's 18, right? So 6 becomes 18 divided by 3. Now subtract negative will become positive. Or what's 1/3 times 3 halves? So we will change 1/3 to be 2 over 6 Well, let's just do this. Add 1 over 3, add 3 over 2. Let's do this for now. So the first two, a minus 18, give us negative 10 over 3. Oops. Negative 10 over 3. Right? A minus 18, negative 10. Then plus 1/3. Plus 1/3 will be negative 9. Negative 9 over 3. What's negative 9 over 3? Just negative 3. It will be negative 3 plus 3 halves. Well, that's negative 6. Oh, you guys did it right. That's negative 6 plus 3 divided by 2. That's why it's negative 3 over 2. Good job, guys. Yeah, I see many of you get negative 3 over 2. Great. Good job. All right. Let's do another one. Okay, polynomial. Yeah, all those polynomials, right? What do we do with 172? Which is
Professor?
Yes.
I'm sorry, can you bring your blackboard back up? So I could take a picture of that answer. If it's still there.
Oh, okay.
Thank you,
It's still here. Yeah.
Okay, thank you.
You're welcome. All right. So now let's try 172. Let's skip 171. So 172, we have the FOIL first. Let me try to do this one right. It's so embarrassing. I always make mistakes. You guys are always right. Let me try to do this one right. Negative 2 to 3. Thank you. Okay, so t cubed divided by 3, divided by 2, 16. But you guys are young, okay? You guys are young and energetic. You try to make less mistakes, all right? To be successful in your life. 3 cubed divided by 3. 2 minus 6 times 3. So that is 1, 2, 3, 2, 2, 17, 6 divided by 2. That is negative 2. Okay. Now at negative 2, get negative 2, 2 plus 12, 12 plus 10, 30 will be 22 over 3. Negative 27 over 2 minus this. 3, 3, 2, 2, negative. Negative 125 over 6. Let's see. 0? I maybe did it wrong again. I get a negative 125 divided by 6. I probably did it wrong again. Okay, we have 0. We have negative 35 over 6. Let's see. Let me check my answer one more time. So when I FOIL, I get t squared minus t minus 6. When I anti-differentiate, I get 1/3 of t cubed, subtract t squared over 2, half of t squared minus 6t. When I evaluate at 3, I get 3 cubed divided by 3, which is 9. Okay, 3 squared divided by 2 is 9 over 2. 9 minus 9 over 2 is positive 9 over 2. Minus 6 times 3, which is minus 18, which is 36 divided by 2. 9 minus 36, that's 27. So I get negative 27 over 2 for evaluation at 3. Then I evaluate at negative 2. When I evaluate at negative 2 cubed, that's negative 8 over 3. Negative 2 squared is 4. 4 divided by 2, I get 2. Negative 2 times negative 6, I get positive 12. So I get negative 8 over 3 minus 2 plus 12, that's plus 10. So negative 8 over 3 plus 30 over 3, that gives me 22. Oh, positive. So positive 22 over 3. So negative 27 divided by 2 minus 22 divided by 3. I make a common denominator of 6. When I add, I get negative 25 over 6. Oh, okay. All right, Paul gets negative 125 over 6. Zachariah gets negative 25 over 6. Are you going to make us graph a song? Graph? What do you mean graph?
You know, you know how you showed us the graph before of the area?
Ah, I see. Let's not care about that.
Oh, thank you.
As long as we understand this. We see this one, right? We see 170, the integrand is a quadratic function. So it's a quadratic function, right? We just find it. What does this integral mean? This integral means find the area of the quadratic function under the quadratic function x squared minus 3x from negative 1 to 2. As long as we understand this meaning, we don't need to graph it. Okay, Ali gets negative 125 over 6. I guess I did it right this time. Negative 125 over 6. All right, so homework. Now let me see homework. Homework will be, so next class will be our third class. All right, so will be our third class. So hope you know you can. So let's start with 173. So 173 up to all good practice. Okay, let's not go into that far. So 173 up to 184. Actually, you can do 185. I haven't talked about it yet. But anti-differentiation, okay, this is all about anti-differentiation. So you can do this. I trust you, you can do this.
Professor?
Yeah.
There's something called conversion day. Can you, are you going to teach us like next week, or what's going to happen?
What day?
I don't know.
Let me see.
This Brooklyn College does conversion day. Like...
Oh, you're right. Okay, you're right. Next Tuesday, no class. So February 8th, we're not going to meet. So I can assign you more homework. But we're going to meet on Thursday, next Thursday, okay? So next Tuesday, we're not going to meet. So, okay, your homework is from 173 up to 189. Let me type in the chat. Also, I'm going to type in the announcement. 173 to 189. In section 1.3, okay? All right. So let me take the attendance again. Okay, I got everything there. Let me see your question.
Sorry, Professor.
Yeah.
Can you go over the question you just did?
Okay.
The answer is negative.
70. This one?
The next one.
Next one, which is, oh, Oh, okay, this one, 172. 172. All right, let me see any other questions. For anyone still unaware, this homework is from the textbook on my open math. Yes. So I should make an announcement on the blackboard very clearly. Thank you for reminding me that. There's a class on Tuesday. It's just following a Friday schedule. Yes. Yeah. Demani is right. There is a class on Tuesday, but it follows a Friday schedule. But for us, we don't meet on Fridays, so we don't meet on this coming Tuesday. All right, let's see this one.
Oh, sorry.
So
is it 172, right?
172, right? Yes.
Oh, sorry, I did wrong thing. I did a 171. Sorry.
Oh, that's why. Okay.
Oh, sorry.
That's okay. That's okay. Okay.
Sorry,
Anybody?
sorry to bother.
That's okay.
Sorry.
Don't worry at all. Don't worry at all. It's good. It's good. Okay. Anybody has any questions? That's enough homework for you to do because we're not going to meet on Tuesday, so you have more to do. Practice is always good. All right. If no more questions, thank you, and I'll see you next Thursday. All right. Have a good weekend. Keep your
Have a
good
good
work.
weekend, Professor.
You too. Thank you.
Bye, Professor.
Bye.
Professor.
Thank you. Bye. Have a good night. Thank you. Great. Thank you.